Lesson 8-3, Graphing Reciprocal Functions. Objective, determine properties of reciprocal functions. Graph transformations of reciprocal functions. Let's take a look at a parent called f of x equal to x. Now, the reciprocal function is a function of this form. F of x is equal to the reciprocal 1 over x. Now, this actually could be not just x, but any linear function. Now, we always have to write this disclaimer that a of x cannot equal to 0, because then we have an undefined situation. But this particular parent, this reciprocal function, this very simple one, 1 over x, has this type of a graph, and it's known as a hyperbola. Notice the domain is all non-zero real numbers. In other words, x can't be 0, nor can y be 0. Now here's another way to write it. Negative infinity to 0, and 0 to infinity. For those of you who like set builder notation, x such that x cannot equal to 0. In other words, all else can happen except for that. As far as a range is concerned, again, all non-zero real numbers, or we can write it this way. And in set builder notation, it would look like this, y such that y cannot equal 0. Let's talk about asymptotic behavior. And one of the asymptotes is this one, where it's the vertical asymptote, and that's x is equal to 0. And there's also a horizontal asymptote, which is y is equal to 0. So we can say f of x equal to 0 or y equal to 0. So this one has two asymptotes. No intercepts, it doesn't cross the x or y axis, and it's not defined at x equal to 0. Now let's talk about end behavior. As x goes to infinity, notice that y wants to approach 0, and decrease, and x approaches negative infinity, y wants to approach 0. So this tells me about the horizontal asymptote, because it's wanting to approach 0 here. Okay, now this function is actually a decreasing function. In other words, as x increases, y wants to get smaller. As x increases, y wants to get smaller. So it's decreasing at all of the domain, negative infinity to 0, and 0 to infinity. So these are all the properties of the reciprocal function. Let's talk about the limitations on the domain. Again, it has a lot to do with the denominator expression. If we factor it, any number that we substitute in here that creates a 0 in the denominator is undefined. So it's undefined at x equal to -8 and at x equal to 3. All right, let's take a look at this function. This is a reciprocal function. Remember, the parent is f of x is equal to 1 over x. So this is a shift for the 1 over x. Now, immediately go to the denominator, x minus 2. And when we set it equal to 0, we can immediately see that x cannot equal to 2. And that's going to be our vertical asymptote. Normally, it would be x equal to 0, but this 2 here shifted it over. So let's go ahead and write down all the answers. Our domain, everything except 2. So you can write negative infinity to 2 to infinity. Or if you like set builder notation, x such that x cannot equal 2. Now the range continues to stay the same. The range for this function was anything except a 0. So negative infinity to 0, 0 to infinity. And in set builder notation, y such that y cannot equal 0. And behavior is really trying to approach this horizontal asymptote right here. That's the end behavior. As x goes to infinity, the y wants to get closer and closer to 0. As x goes to negative infinity, y is equal to 0. So this has a lot to do with a horizontal asymptote. And our horizontal asymptote is y equal to 0. And our vertical asymptote, so that's the horizontal asymptote, and our vertical asymptote is x is equal to 2. Now this is not an increasing function. This is actually a decreasing function, just like f of x is equal to 1 over x. It's just been a shift. So it's going to be decreasing for all the domain, negative infinity to 2 and 2 to infinity. So those are all the properties of this reciprocal function. Let's take a look at another reciprocal function. And this is a slight change here. Notice that there has been a change in the denominator. Remember, our parent is f of x equal to 1 over x. And normally our horizontal asymptote is y equal to 0, and our vertical asymptote is, I shouldn't write equals, it's going to be x is equal to 0. Our vertical asymptote is normally on the parent function, but you see this has been shifted, and let's go ahead and set that equal to 0, and you can see the shift has gone to x is equal to -2. So this is our vertical asymptote now instead of what it was before. And it looks like also our horizontal asymptote has changed, and it looks like right here, normally it was y equal to 0, but it looks like it has shifted up 1 unit, and so that'll be y is equal to 1. So there has been a shift in the horizontal and vertical asymptote. So let's go ahead and write that down right now. X equal to -2 is our vertical asymptote, and y equal to 1 is our horizontal asymptote. Our domain, remember, x cannot equal -2, so I want to go from -infinity to -2 and -2 to infinity. Set builder notation, x such that x cannot equal -2. Our range, remember that our range is from -infinity, but we're not allowed to have 1 to infinity. And our set builder notation will be y such that y cannot equal 1. So either you name all of the things that can happen, or set builder notation just says what it can't be. Now the end behavior is what the x wants to follow as it goes to infinity, and it's going to want to follow 1. And this is not unusual because that's the horizontal asymptote, y equal to 1. So it wants to follow that horizontal asymptote. It's not an increasing function, it's just the parent that has been shifted, and so it's decreasing over the same domain as before. And so I just write the domain, and that's where it's decreasing as well. All right, let's go ahead and do it again. I'm noticing there's a shift in my x and a shift in my y. X minus 3 is equal to 0, so x equal to 3 is going to be my vertical asymptote, and that's this thing right here. And my horizontal asymptote has to do with this. Normally for f of x equal to 1 over x, y equal to 0 is the horizontal asymptote. So the horizontal asymptote has been shifted down, so y equal to -2 is now my horizontal asymptote. I'll go ahead and write those in right now. X equal to 3, vertical asymptote, y equal to -2, horizontal asymptote. My domain is, remember, I can't have 3, -infinity to 3, 3 to infinity, or in set builder notation, x cannot equal 3. Range, -infinity, and I can't reach -2, and then from -2 to infinity, and set builder notation, y such that y cannot equal -2. Remember the end behavior as x goes to positive infinity or negative infinity, it wants to go to -2, which is not a surprise because y equal to -2 is my horizontal asymptote. It is not increasing because it's just this parent function that has been shifted, so it's decreasing over its domain, -infinity to 3, 3 to infinity. Okay, your turn. Pause and see if you can do the problem. And here's the answer. Pause to see if you can do the problem. And here's the answer. Pause to see if you can do the problem. And here's the answer. Pause to see if you can do the problem. Here's the answer. Pause to see if you can do the problem. And here's the answer.